So this is the session of Light Camera GitHub Actions. And we're going to talk about, obviously, GitHub Actions, but also with Java and Maven. So in the program, this session was only for Andres Almiray, but in this case, I'm going to also present with him. A little bit about me. Well, you saw in the morning that I'm the head of the content committee program for this conference, but I also participate in different foundations, the OSSF, the CNCF, the OWASP, CDF. I'm a Java champion. I participate in some books. The latest one is DevOps Tools for Java Developer. And currently, I'm on a sabbatical that will start the end of this month. So I will take 3 months to come up with my next adventure.
So I am Andres Almiray. I'm also Java champion, and like Ixchel, we're coming all the way from Mexico. We're living in Switzerland for quite some time now. We love to be here. And one of the things that we do is travel around the world, talking about experiences that we have had in our daily jobs, working in open source and closed source, commercial source. And that's, even though my official title sounds very, fancy, I like to call myself a seasoned sorcerer because I like to work with source code.
Okay, so why GitHub Actions? Why we decided to dedicate an entire session about this?
First off, who is using some sort of DevOps or CI/CD solutions? Okay, most of you, right.
Who is using
Who's using already GitHub Actions?
Okay,
a handful.
So
good.
I really hope, well, you will see my last question, and I hope you answer affirmative. So why GitHub Actions? So this is according to the October's, the latest report, 2022. So there are 94 million developers on GitHub. And if you see the amount of build minutes a day that they are doing through GitHub Actions and the different workflows, is huge. And also we're talking about GitHub Actions in conjunction with Maven and Java, because this is still the third programming language on GitHub. Java is still the third one. It lost one position to Python, but we're still on the top three. So what are GitHub Actions? And probably this is your first answer. It's just to automate your build, test, and deployment pipeline, which is true. That's it. But it's not only that. It actually allows you to run workflows, and the workflows can be as creative as you want them, and when events happen inside or outside your own repository. So this is how I see GitHub Actions. So there's a bunch of events that trigger the workflows that contain jobs that define a series of steps that executes actions. And as you can see, I added these lines to say that the jobs can run in parallel or in series. There are two important considerations of the runners, and probably you already know. There are GitHub hosted and self-hosted runners. And they also provide different kind of operation systems, Linux, Windows, macOS, and with different architectures.
Yeah, so what is important is that the managed runners by GitHub, they're all Intel-based, macOS, Windows, and Linux. And if you want to run ARM-based runners, then you have to do it yourself. Now, luckily for you, there are many cloud providers that offer ARM solutions for Linux and for Windows. For Mac, unfortunately, those are the others that I mentioned that are available for free for all cloud providers, pretty much. But for macOS, in case that you have to run macOS, then you either provide your own hardware or pay someone else to provide that hardware. There's no other way for it.
So this is actually the long definition of a workflow. A GitHub action. Well, a workflow contains more than one jobs which can run sequentially or parallel in each of our virtual runner. Inside a container contains more than the steps, and you can run scripts with different actions. So the first step is what are the workflow triggers. And we can respond to events inside your workflow repository or outside your GitHub repository, and we will see how that happens. Let me tell you that I'm going to try to explain the basic concepts, but some of the gotchas that we have found ourselves when using GitHub Actions. For example, one of the gotchas that is really interesting is that sometimes you are creating a new workflow in a specific branch, and you cannot run it. And why is that? Because usually a first definition of the workflow has to exist in the main branch. So this is important.
Yeah,
so
this is quite a gotcha. When you're working on a new PR, you have a new workflow, you put it in the branch, the feature branch, you're about to merge the pull request, but you want to run it from the default place, and you cannot simply find it because it's not there. It's until that pull request is merged that you will see it. Now, using the UI, you can select on which branch you want a particular workflow to be run, but this is right after the fact. So you have to set up your CI/CD on GitHub Actions in such a way that you can run certain workflows on certain PRs. It's not as easy as this new workflow that is part of the new pull request is going to be run automatically for you. No, that's not how it works. So be careful about that.
So these are the huge amount of events that you can respond towards. And probably these are the ones that you already know, because of those are the most popular: create, pull request, push, release, and workflow dispatch.
Right, if you go a little bit back. So push is what you usually would do whenever someone sends a commit to a particular branch. Whenever someone creates a pull request, there's another workflow that could be run. Or when someone creates a release, or in this case, workflow dispatch is where you manually say, I want to run this from the UI. But there are many other ways that you can react to this. For example, someone creates an issue, or closes an issue, or adds a discussion topic, or some other kind of event happens.
So for example, the create event includes all this kind of types. Commit is push, commit tag is push, the branch is deleted, a tag is deleted, and a repository is created for a template. But watch out, some of them have limitations. For example, if there is a branch or an issue or that has more than 3 tags, none is going to be executed. So read the small print in some of these events. And how do we trigger the workflow? As we mentioned, they can be manual or they can be a schedule. And this you probably have seen it most of the time. So this is like cron nomenclature or a structure. So this particular workflow is going to be triggered every day at 5:30 and 5:30 in the morning, 5:30 in the evening in UTC times. And we have here, because you can actually add multiple lines, multiple different schedules. And in this particular one, we have also here how to control and create even a more granular control on how things are going to be executing. For example, this is a conditional where it says this step should not run if it's actually Monday or Wednesday.
And what is also important that you can have multiple triggers with different variations. You can have a manual trigger, a cron expression trigger, or a push trigger for the same workflow. That gives you the option that, oh, I want to run this every Monday in the evenings, but also whenever I want to, I can just manually trigger this thing just to check something.
And this particular remark will help us realize when we are working with concurrency groups how to actually work with default values, but I will explain that in more detail. So how do we trigger the workflows? So as we said, this was on push, a single way, multiple ways, as Andres mentioned, with event activity types. For example, every single type, a label is created, or there is a push on main, or there is a page build. And this is something that you also need to make sure that you know and understand what is happening because of all these possible triggers. So for example, if we have this, when an issue is open and labeled, this workflow should be triggered. This particular workflow is going to be triggered 3 times if you open an issue with 2 labels. And the 3 times belong 2 for the labeled and 1 time because it was opened. So it's important that you keep that in mind. Now that we have seen that we can execute or trigger the workflows in different moments, it's important that we also use some kind of filters. So in this case, you can say, only if there has been a change on main or in this kind of format for the branch. The other thing that it can help you a lot is branches ignore. So if there is a push on, or there's actually a pull request on any branch except that one's, do this. What would happen if we try to combine branches and branch ignore? Well, you have this nomenclature. This is when this actually element can be used. And because you can obviously don't use branches and branch ignore in the same definition. So you have to use that particular syntax. But it is important that you remember the order, because this also matters. If you first declare the negative one, and you declare in the second level the positive one, actually, in this case, you will be invalidating the first definition. So it will run on all releases. But how it's expressed right now is in all the branches that have release, except the ones that ends in alpha. So the position and the order does matter. And you can follow the same logic with tags. You can say, add these tags, or these tags should also trigger this particular workflow, or tags ignore. And the same syntax is valid for when you want to combine both filters. And guess what? It also works for paths. So if I want to react to modifications on the documentation files, or not on the documentation files, or in some type of file type files, it also helps. Okay, so how do we communicate between workflows, or jobs, or steps? So these are the main ways of communicating or passing values between different jobs. With the context, with variables, environment variables, defining outputs or defining inputs. So, for example, a way to access information is through variables, runner, environments, jobs, and steps. And we will see how. It's using the context. And you can also use the expression syntax like that. One important thing about the variables is that they are going to be localized for the different kind of runners. For example, if you're using an Unix-based runner, how do you express and use the variable is going to be bash friendly. If you're using a Windows runner, then it's going to be PowerShell friendly. And this is going to be interpolated by the GitHub Actions, so you don't have to worry about that. It is important that everything that you use in the variables is non-sensitive configuration. Because secrets, I will explain a little bit about secrets and what is the risk when we are working with this. So if you're trying to pass compiler flags, servers, username, servers variables, use this. All these variables can be modified when the runner is executing.
Okay, one more thing. If it wasn't apparent already, writing GitHub Actions require you to write YAML. Who likes writing YAML? You got the ruler, perfect. See, it's actually a GitHub Action workflow. It's a combination of YAML, that is the enclosing format, and the definitions on the actions, if they are custom-made actions, they're pretty much bash script, shell scripts, or PowerShell scripts. So it's both the YAML and scripts depending on what you're doing. So be aware of that, and that's what Ixchel mentions. The way that we define the format for resolving the variables depends on where you are in the file. Sometimes it's part of the YAML context that has nothing to do with scripts. And whereas you're inside a script, then you may use one format or the other depending on what exactly you want to do.
And the scope, it can be defined at the top level, at the entire workflow, at the job level, or at a specific step level. The environment variables only exist when the runner is being executed. So if you want to have information passing before or after, you will have to use something different.
There are no constant values for a script, like constant variables. You can fake them using environmental variables because they're available for the whole workflow.
We will see examples of that. But this is, for example, at the workflow level, this is at the job level, and this is going to be at the step level. And as you can see here in the example, they are saying greetings, first name, today is day of the week. So we are using at the workflow level, we are using at the job level, and we are using at the step level, and everything is available on the run part of this workflow. But what happens here? Why do I have end dot day of the week?
So notice there's a different syntax here, and there is a prefix.
Why it's not the same one? It's the same one. Why I have to specify it differently? Well, turns out that the runner environment, this part is not available to the runner because this particular conditional is decided by GitHub Actions before sending it to the runner. So for this kind of structures of the conditional that are going to be only processed by the GitHub Actions, not by the runners, you have to provide it like that.
So that's why I said that depending on what you're doing, this is part of the YAML environment for simplifying things, and this is part of the script environment, which is the one run by the runner. And this is what I was telling you before. This is kind of like faking a constant value because it's available for the whole workflow. Whereas these two have a shorter scope.
But this was during a single workflow, what Andres said. We have the scope and the entire workflow and between a job and between a step. But what happens if we want to communicate between multiple workflows? So for that, we need to use the vars context, and we will see the example. So here is exactly, we are actually creating at the environment level an envar, and we're calling the vars context for the environment context var. And then if you can see and how we're accessing it all around the different workflow is through that particular map object.
And you may be wondering, what is this context? Where is this context defined? If you go into the UI and setting of the GitHub Actions, there are places where you can add certain values. There are the secrets, for which you're not supposed to see the actual value when this thing is running, when you see the log. And there are the variables, which are supposed to be just plain text values. And that's where you can define the values for both of those things.
So what is available for you at the context level? You have information about GitHub, the repositories, the SHA, the commit. You have a context of the job, like which one, what's the name, et cetera, like the PIDs. At the step context, what are the inputs, what are the outputs? The runner context, some information about the runner at the specific level, the strategy, and the matrix context.
These are actually the context objects. As we saw in the past with and vars, they contain different values. And this function, what it does is transform that object into some JSON format that this could be expanded into multiple values. So you could use these two JSON function for any other things. It just takes a JavaScript object and expand it into a JSON literal.
So one of the things that are really important about that we mentioned right now is the secrets. GitHub Actions will try to do its best to not print out the secrets. But if you're using a very complex object, not a direct string, then GitHub Actions would not be able to extract or mask or redact that from your logs.
And here's another gotcha, which they have not plugin. This is a security risk. Let's say that the value of a secret is any word. It could be
Hello world.
It could be Basel 1, right? So anywhere in the execution log where the text Basel 1 is found, it doesn't matter if it's just one token or it's Basel 1-2023 or 23-Basel, whatever it is, as long as it's Basel 1, that thing is going to be masked. So if you know that there is some public data that says this is my workflow for Basel 1, blah, 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 and suddenly gets masked, then you know the value of that token. Be very careful with the values of your tokens.
So don't use a very known word
Don't
that
use a
you're
word
going to
that
be
is-
repeated.
Yes, exactly. Be careful.
So how do we find another way of communicating between different workflows? It's going to be through outputs. So for example, when we add or specify an output in a workflow, well, we are creating a map of outputs. So you can have only Unicode strings for the outputs. They can be maximum of 1 megabyte. And the maximum amount of information that you can store as outputs between different workflows, it's 50 megabytes.
So, and here's the reason why. Because if we didn't make it clear before, so the workflow is comprised of at least one job, and one job is comprised of at least one step. Jobs are run on containers. Each job runs in a separate container. There's no way that you can share files or data across jobs. So the only way for now that we can share information across jobs is through these literal informations, outputs and inputs. If you want to share a file or something else that is not a literal, there is an option we will talk later.
Well, and the other thing that you have to keep in mind is any output or artifact created as part of a workflow, for example, the artifacts created or logs or et cetera, are going to be maximum kept in the retention for 400 days. But you can also modify that.
You can configure this in the UI.
From 1 to 400 in the UI and at the YAML file level. So for example, this is how you define the outputs. And this is very straightforward.
We have a workflow that contains 2 jobs. These 2 jobs will run in 2 different containers. We have this one that defines 2 outputs. Notice that I have a list of steps. You can define an ID, any text that you want. And this is the syntax to output a key value into what is known as the GitHub output context. This key will match to that. And this key will match to that one because of the IDs of the steps, right? So at the end, job 1 will have 2 different outputs, which we can consume here. This is another context, needs. So before job 2 runs, job 1 must be run. So these things are now in sequential order. Because that wasn't the case, this will be run in parallel order. So because this is now sequential, I can have grab hold of that context, job 1, outputs, output 1 and output 2. This is how we share information across jobs.
Okay. So, and again, this is for, this is for inputs. And I love this particular one, and I hope you're using it. So there are already different type of inputs. If you haven't used them, I strongly suggest you to do. Because, for example, if you use the type choice, you can define the choices. You can to have a type Boolean, and you will see the results, and a string and an environment. So this, when you're running your workflow, it's going to appear like this. The log level, you have the Boolean one. It's a checkbox. And you have, well, this one, it's a drop-down menu. So if you had some information required from the user or from wherever, an input with a specific type, now you can make it more user-friendly and reduce the level of confusion.
Right, so these are the 4 inputs that Ixchel defined in the YAML. You notice that it's a 5th one that we didn't define. This is what we were telling you before, that once you have a workflow available at the main branch, you can call it, you can invoke it on any other branch that you have in your repository. This is always available in the UI.
Okay, now so let's talk more about the jobs. So Andres already, and we saw it a little bit on the inputs, when Andres said, well, we can run them sequentially, because by default, they run in parallel. And it can run in the runner environment it's specified by the runs on. So at the beginning, when I showed you the schematics of how a workflow looks like, I mentioned the GitHub hosted runs and the self-hosted runs. One of the things that are important is that the GitHub runners have some versions of the operating systems that are very reduced. Well, not reduced, actually. They are the latest one. There are 3 for Windows, 3 for Unix, and I think only 2 for Mac. You can read the documentation about that. But in the self-hosted, you have more options about what are the different versions of operating systems or architecture that you can have your own runners. One of the things that you have to keep in mind is, of course, if you are self-hosting a runner, you have more control in the configuration and the environment of those runners. There are things that you should, or people usually opt to use self-hosted runners is because they don't have to be clean between runs. While the GitHub hosted runners, they always start with a fresh environment. They are unlimited as long as you are within the workflow usage limits. And these are the limits. So, for example, there is a limit in the job execution time. Any job has to end before 6 hours. If not, it's going to be terminated. And the actual outcome is going to be failure.
Yeah, so that means if you're running test cases and it takes more than 6 hours, something is really, really gone wrong. So fix it somehow.
No, but also the output is going to be important, and we will see why. If the workflow can last until 35 days, if not, it's going to be declared as cancel. And you will be asking yourself, why would it be running for 35 days? Because it also includes the time of waiting for example, a peer review or updating or something like that. A workflow can have different stages. Sometimes we think about like only on push, only on, but as we said, you can automate whatever you want. And some people have the need to automate an entire workflow that requires different stages of the development process. But the maximum amount is going to be 35 days. You can only have 1,000 requests to the GitHub API in an hour across all your repositories. And there is only 20 different concurrent jobs that you can execute. Of all those 25 are maximum in macOS.
Right, so you can run 20 different runners on Linux, but you cannot run the 21st. That's a given, that no way. And if you are running 5 macOS and you want to run the 6th, you have to wait until one of those 5 finishes until you can get to the next one. I personally have hit this limit in my own project, Jerelisa, which because I build a lot of things, and I have to do a lot of testing on macOS, and I'm limited by those 5 runners. So if you need to test on macOS, you have to be aware of these limits.
Are these limits applied also for self-hosting?
Yes.
So the limits apply for self-hosting? Yes, that is correct.
For macOS, it applies on the self-hosted. Yes, you don't have that much benefit.
Okay.
Yes. Yes, and I find it that very curious. When I was reading documentation, I was like, well, but I'm paying for that.
You will have expected that if you have your self-hosted runners that you will be beyond these limits. There might be some sort of limitation through the platform itself, not just because they're self-hosted.
Okay, so when we want to run them sequentially instead of parallel. So as we saw in the previous example, we can use the needs. So we're saying that job 1, we have a definition, job 2 depends on job 1, and job 3 depends on job 1 and job 2. Very straightforward.
Right.
But now I have this other example and says almost the same thing, but I have this very strange statement. So what do you think is the difference between that? Exactly, Because here, job 3 won't run unless job 1 and 2 are successful.
If job 1 or job 2 fails, then job 3 will be skipped. In this case, if job 1 fails or job 2, of course, job 2 fails because this one is required explicitly. But this one says, I don't care. If there is a successful or failure here, I will still run. But I will run after I figure out what's the state of these two.
Yes. So it's still going to run sequentially, but the output doesn't matter. Oh, okay.
So the question is, what's the value of the outputs?
Okay, I will show you the example. I was going to...
Well, it depends. It depends if the step that has pushed the outputs to the GitHub output context has run successfully or not.
Okay.
Yes, the value of the context variable you're expecting should be empty.
Okay, so we have the example here, and let's first go into the very beautiful description. And I'm saying beautiful description because it accepts Markdown and even emojis. So bear with me because I did this one. Well, I did everyone, but okay. So the job 1 says it's okay. The job 2 says depends on job 1, okay, but step 01 will fail. The step 2 in the job 2 was triggered because the step 1 has failed, and job 4 depends on job 1 and job 2, and regardless of the status.
By the way, this text is custom text, the custom text that you can write.
Yes, because I don't want to go directly into the job, and let's hope that there is network.
And that graph is generated automatically by the GitHub UI, so you can see the dependencies within the jobs and their states.
So I didn't want to do this, so that's why I put it on the GitHub output. So let's see a little bit of the YAML. So this is how I'm doing the markdown, and this is how I'm sending it to the GitHub step summary, and you will see at the end how I'm just printing that out. So job 2 in the step 1 of job 2 depends on job 1, and here's I'm making it fail. Like literally it will fail.
Yeah, so any return value other than 0 will make the action fail.
And then here's the interesting part. I'm saying if there was a failure, and I'm actually asking, like, there can be any kind of failure, but I'm actually asking here, it was the step 1 of job 2, the conclusion was failure, then I want to run this particular script action.
Which will be that one.
Where I only say step 2 was triggered because step 1 has failed. So this is a way to react to something that has happened. And job 3, in this case, it's depending normally. So because it's going to job 2, it's failing because I said you should fail. It's not going to be run.
Yeah, this is skipped.
This is going to be skipped. That's why we see that in our graph. But job 4, it's going to be run regardless if job 2 has failed. Okay. So let's see. Let's go back. And this is exactly what happened. Job 2 failed because we had an exit 1. Job 3 is going to be skipped, and job 4 happens.
Because it has an always. Mm-hmm. Okay.
Okay. Sorry. Okay. Now, conditionals. We have seen a lot of conditionals. So these are the different examples. So we can actually do on expressions. We can have on different context. If the event name is a pull request, if the event action is an assign. So this particular event is when a pull request had an assignee removed. So you can even react to those kind of stuff.
There are a handful of built-in functions like this. We saw to.json before. Now there's a start with as well that you may use to manipulate literal values to find out if they match a particular expectation.
So there is a starts with, contains, ends with. You can guess the entire number of functions that you can start with that. And you can also negate them if it doesn't start. Concurrency. we have seen that you can trigger a workflow with different things. And actually, as Andres said, you can have on workflow dispatch, on push, on pull request, on created. So at some point, there are going to be different origins or sources of a specific workflow. And because it can be triggered by different things, the context that is going to be attached to that specific run is going to be, can be slightly different. So I want you to have that in mind for these next examples. So what happens if we keep triggering workflows after workflows because we're changing a small, or we're changing in small increments our workflow or our code?
Well, if we have a push on main, a trigger, then every push on main will trigger a new version of the workflow, and that will run until it finishes or it fails. So you keep more workflows and workflows until you reach the 20 maximum number of workflows. You don't want that. You probably want the current workflow to be canceled, and then the next one continue.
The newest one.
Or you want the current one to finish until the next one could run and wait. And so for that, we use the concurrency groups. And you also have this option to cancel in progress, so you only have one instance of a given workflow for every time that you're pushing that trigger.
Because in a specific event can trigger different workflows, you want to cancel the broader group of things that were triggered in the past because of a specific change. So the groups, the names of the groups can be made by expressions like this, and this can be as creative as you want. But again, why do I have this? Because this is a default value. And why do I have to have fallback or default values? Because again, if it was triggered by a workflow dispatch or by a pull or a pull request or even Gollum, which is creation of a page, then the context attached may be different. Maybe I only have a runner ID, or I have a branch that was triggered, that what started that specific trigger. So make sure that your concurrency groups names are unique across workflows. Because if they match, you will start killing workflows very fast. Okay, who is here using reusable workflows?
Who here loves refactoring code and removing duplication? Right. So one thing that is very common with GitHub Actions is you start doing something very, very basic. So you get the basic workflow, how to build a Java project using Maven. Boom, you're done. And then you start adding a few more things, and then, oh, I need to test on Windows, and then on Linux, and then on Mac. So what we do, the easy thing is copy the current steps that work for Linux, and then create another job running on Windows, and do the same for macOS. So now we have 3 times the same configuration. But there may be a slight minimal change for specific to Windows, another for Mac, and then what we end up is with thousands of lines of YAML code. Amazing. But if we are able to reduce that duplication into what is a common place that could be conditionally triggered and conditionally written in such a way that has these conditions, then we can move all that code into a secondary script. This will be a reusable workflow that can take additional inputs, similar as we saw before. Now the advantage is that your original script, instead of having 3 times the same thing, it will have 3 jobs invoking your reusable workflow. So that is much more readable, much more maintainable at some point. If you start adding too many reusable workflows, there might be another kind of problem.
Okay, so the gotchas here. You can only connect 4 levels of workflows, so that's the amount. You can, a maximum call of 20 reusable workflows. They can exist at the repository level or the organizational level, so you have more options in that regard. The other 2 things that you have to be very aware of. Environment variables are not propagated to the called workflow. Environment variables are not accessible to the caller. So that's why we spend a little bit of time explaining how to use the bars context, because this is the way that you're going to communicate reusable workflows.
There is another workaround. You can use inputs and outputs. You can have another previous job export an environmental variable as a job output and then use it as an input to the reusable workflow. It's a hack, but it works.
It's a hack. So, yes, it actually is. But this is, don't worry, there was not the intention that you read the entire reusable workflow, because here we have the one that we're going to call and the caller. And as you see in the caller, it's very, very simple. We are only saying that we are using the call-it workflow, and here, we're only consuming the outputs. The output is going to be hello world.
Because this reusable workflow defines outputs, just like we saw before. Now, the important thing here is that you can put the whole path to a given repository. This is a repository in my same organization. Where's the file and the particular tag or version or SHA for that file. But you can also put it, if this is the same repository, if these two files exist in the same repository, then you can omit this and just use the .github. The advantage is that with this syntax, you may keep reusable workflows on a secondary repository that may be applied to another set of things. So you may have a whole set of reusable workflows for your whole organization that may be called from different repositories in the same organization.
The other thing that you have to be very aware is how do you pass secrets. There are usually two ways. Either you pass all the secrets between the different workflows, or you pass only a specific subset of secrets. And this is, you always go from the more open strategy to the least open strategy. So if we depended on D cannot pass, again, all the secrets because they don't have it anymore.
Secrets, this is another context object as we saw before, like GitHub, bars, or M.
This, of course, is, I strongly suggest use that you only use Unicode strings, because you can use whatever you want, but if you don't use Unicode strings of maximum 65,000 characters, 61,300, you know the number, it's not going to be masked if in any log or in any specific print out of the different context or environments. And the GitHub token permissions can only be the same or more restrictive. I didn't show the different levels of permissions that you have on different things, like, for example, on issues, on status, on security, but that's also a very, very interesting topic. And I didn't add it because we want to show you the demos.
We got about 7 minutes.
Yeah, I'm going fast. Well, let's do the Java.
Okay. So here you have the very basic way to build a Java project with Maven and GitHub Actions. It's running on Linux. And we have how many steps? 1, 2, 3. You can define names if you want to. And this thing is using a built-in action. This will know which SHA or which Git reference should be checked out automatically. I don't know if this is the latest version or not. I think maybe before or so. So you can also define a SHA here, a tag, or a branch for anything you want to. Here's another action that will set up Java, the JDK for any given vendor, a Java version. And this little thing here also will cache your Maven repository. Because as we know, every time we build with Maven, we download a copy of the internet because of dependencies. So if we don't cache your Maven local repository, every time you run this workflow, you will spend time downloading those dependencies. This will make sure that those dependencies get cached for the next time. And then we just invoke regular shell script here, bash. We change into a directory just because how this repository is set up. It has multiple repositories, multiple source sets within the same repository, and then just invoke any commands as you would do in your local environment. Here we have another one. We have one job running on Linux that has one output. That output is from this step. We do checkout, we set up Java, we run Maven to find out what's the version on the POM file, and we export that version to what we saw before, the GitHub output, and that's what we get there. Then we got the second job. As we know now, this has a dependency, so version runs first, release later. Only if the version is a snapshot version, then we're going to run. Otherwise, if this were to be a release version, then this step will be completely skipped. So this is kind of like a nightly build. Okay, what do we do? Run on Linux, check out, set up Java, run the build. So this makes sure that we are running an early access release, but without knowing it when it's not an early access release. Yes, a question about that.
But is that not super inefficient that we set up Java twice and check out twice?
It's a little bit inefficient in a sense, but remember about the caching here. So yes, we're going to do the checkout twice. We're going to do setup Java twice. But the setup Java action is smart enough to figure out that what is already in the cache, if the runner has been already configured within the two containers, the next time should be a bit faster. It's not going to do double the whole work all the time.
But if the second time is running in another container, where does it cache? Somewhere outside the container.
So the question is, what happens if those two things are running in two different containers? Where is the cache? The cache is in another storage location that is fully available to all the containers within the workflow. So does it caches the target from Maven the build? Not by default. This is only for Maven local. But you have access to the standard actions cache action on which you can specify which paths and which restore keys should be used to do the match. This action automatically calculates its own restore keys and matching keys. So either if you know the path that they will use or the kind of algorithm, you make it the same, or you use your own custom keys.
Okay.
Yep, question?
When you say Java, Maven comes automatically with it?
No, Maven does not come automatically with it. Maven is already installed on the runners, but you will notice that I use my good friend, the Maven wrapper. If you do not know what the Maven wrapper is, it's a script that allows you to bootstrap Maven for a given version. It's going to become the standard with Maven 4. I know that we're still in Maven 3. But if you're not using Maven wrapper, please do it right after this session. Start using Maven wrapper in your own projects because of this reason.
Okay, well, in this example, we also are creating a matrix for different operating systems.
So this is the case where, oh, I need to run this on Linux and Mac and Windows. What do? Copy and paste and change. Now we're doing a refactoring that we're going to do the checkout, the setup Java, and the build for all these three different operating systems. And what is changed here is that we have this concept, a strategy called a matrix, where we have the three operating systems, and we have access to these variables here. Matrix, OS, this thing is the thing that matches. Again, using sort of a scope. So with now this, we'll run the version once, and we run the build for the three systems, the operating systems, separate from one another. And each one of them will run in parallel because there is no dependency here.
Okay. Next example, a little bit of repetition.
So we go up. There is assembly on Linux. We depend on the version. What we do is check out, set up GraalVM with certain settings, set up the JDK, do the build. And then we run another action called assemble that generates some zip files. We store whatever output from the log, whether it's successful or not. And then this is the last thing that we're sharing information across jobs. With this, we are storing this zip file, an artifact, in some storage location so that that file, instead of a string, will be available to other jobs or even to other workflows.
But only for the day.
Right. And then we do the same thing for macOS. If we do a diff, this step is pretty much the same, except for, I think we said, what is it we doing here? No, it's the same step, I believe. I thought we had something different here.
We do
we install UPX. This is different in Mac because you use Homebrew. But the rest is pretty much the same, so that's the only difference. And then for Windows,
we do the same thing.
It's almost the same as Linux. So there's plenty of duplication. Yes, this works. But if you need to change how they do the artifact or uploading, then you have to do it 3 times. And then finally, we have one step which is called the release, which does the checkout, depends on everything that we saw earlier, the other jobs. We download all the artifacts, and then we perform the release, and we're done.
And as you can see, 244 lines, so not so great. This is the refactor way, which only has 74 lines of YAML.
Right, so we can see here in the color, which will be number 5, I believe.
Yes, this is number 5.
This is number 5. We set up the version as earlier as before, and then we do the assembly. Notice what we do with assembly. We use the reusable native assembly. This will be the reuse for Linux, Mac, and Windows. And then we just do the release as we saw earlier. So this is the refactor way. Instead of 3 blocks of duplication, now we have it here, and that file is found here. And that file has some inputs that we require for setting up Java, GraalVM version, and then we do the part of the assembly, which goes into the different operating systems. And the path for the UPX, somewhere here,
54.
has a conditional, only if the running is Mac, and everything else is the same. Last thing I want to mention is that all your workflows, including reusable workflows, exist at the same level. There are no folders, there are no categories, nothing whatsoever. So depending on what you name your file, you will see it in the list. For that reason, and it's my convention, I may use an X or a set for defining the names of a reusable workflow, because these are secondary. I want to see the primary workflows listed first.
So that was a part of the demos and the GitHub repository. The slides will be available, and that's actually the QR code for the GitHub repository. And with that, I will add the QR code. And yes, with that, thank you very much for being here. And if you have questions or feedback, please let us know.
Thank you for your time.